Good evening all. Last class we have seen the general working principle of tidal power plant. We have seen the site selection criteria as well as the advantages and disadvantages. Today we shall see the classification of tidal power plants. So the tidal power plants are classified based on the number of basins used. First one is the single basin system. We know that basin is the reservoir where the water is being stored during flood tide. So single basin system and double basin system. As the name implies, single basin system consists of one basin only. Double basin system consists of two reservoir systems. The single basin system can be further classified as single ebb cycle system, single tide cycle system, double cycle system. We shall see them one by one. Single ebb cycle system. In single ebb cycle system, when the high tides or flood tide occurs, sluices are opened to permit the sea water to enter the basin, while the turbine sets are shut. Brake is applied on the turbine. The level of the basin begins to increase. The energy is stored in the form of potential energy of water in the basin. As the head becomes greater and greater, the potential energy will be more and more. The tidal range provides water head during low tides. The generation of power takes place when the water from the basin flows over the turbine into the low level sea water. That is, the water from the reservoir goes back to sea when ebb tide occurs. When the sea level becomes lesser compared to the basin, the water is allowed to flow from the basin to sea. At that time, the turbine brakes are released. The turbines are designed for single wave operation. The power output from such a system is intermittent in nature and highly variable. Next, single tide cycle system. In single tide cycle system, the power generation is taking place when the sea is at flood tide. The sea water is admitted into the basin over the turbines. The turbines are allowed to move with the flooding water. As the flood tide period is over, the sea level begins falling again. The generation is stopped. The basin is drained into the sea through the sluice ways. In this system also, the power output is intermittent. That is, the generation takes place only during the flood tide period. Third one is the double cycle system. In double cycle system, the reversible turbines are installed and the power is generated during flood and ebb tide. Filling process occurs when the ocean is at high tide, while the water in the basin is at low tide level. The emptying occurs when the ocean is at low tide and basin is at high tide level. The flow of water in both directions is used to drive the reversible turbines. The turbine drives the generator during flood and ebb. In this system also, continuous generation of power is not possible because of short duration. Here we can see the high tide condition or flood tide condition. Sea water rises and water begins to enter the tidal basin through the sluice gates. This is the ebb tide condition. Sea level is below the level of tidal basin. Water can be allowed to flow from the tidal basin to sea so that the turbine can act. Next general classification is the double basin system. So far we were discussing single basin system and its classification. Now we are going to study about double basin system. There are two basins, namely upper and lower basins, kept at different levels. A dike is provided between sea and the basins as well as between two basins. The powerhouse is located in each of the dikes. The hydraulic turbines are located in the dike. This is the diagram of a double basin system. You can see the upper basin as well as lower basin, and also sluice gates are there between the sea and upper basin. Then between upper basin and lower basin, again we are having a sluice. Then one more sluice is there between sea and the lower basin. So sluice gates are provided at different locations. The sluice gates provided in the dike allows the entry of water to the basins. The high-level basin gates are called the inlet gates and low-level gates are outlet gates. The upper basin is filled with water initially during flood tide. So, we are having inlet sluice, that is to the upper basin. Water is get collected in the upper basin first to the inlet sluice. Then there is an outlet sluice, that is from lower basin to sea. So water is allowed to flow out of the basin through the outlet sluice. During flood tide, water is allowed to enter to the upper basin through the inlet sluice. When the water level in the upper basin A reaches a sufficient height between the two basins, the sluice gate between them opens. Between upper basin and lower basin opens. And water is allowed to flow through the turbines and generation starts. The power generation thus continues simultaneously along with filling up of water in basin A. When the tide attains its peak value, the water level in basin A is maximum. So, when there is a sufficient head between upper and lower basin, during flood tide, water is entering through the inlet sluice, and when water level of the upper basin reaches at a sufficient level, it is allowed to flow through the sluice between upper and lower basin. So the power generation starts by rotating the turbine in between. Okay. So at this time, water level of the sea rises and simultaneously upper basin is being filled. And when the flood tide is maximum, the head of upper basin becomes maximum. When the water level in the upper basin falls, that in the lower basin rises. So we know that the water is getting filled in the upper basin and reaches maximum, and slowly the water is allowed to flow through to the lower basin. So the water in the lower basin also rises. When the rising level in lower basin B becomes equal to the level of falling tide, the outlet sluices are open and the water is allowed to flow out of the lower basin to sea. When the tide reaches its lowermost level, the outlet gates are closed. So the tide is finished. When the ebb tide is being ebb tide reached the lowest level, the outlet gates are closed. Again, when the tide rises and its level becomes equal to the lower level of the upper basin, the inlet gates are opened. The process is being repeated. Consequently, the level of water in basin, upper basin starts rising. Thus, the cycle is being repeated. So, during flood tide, upper basin is filled. When sufficient head is attained, water is allowed to flow to the lower basin with the power generation. When there is ebb tide, water is allowed to flow to the sea from the lower basin. When minimum of ebb tide is reached, all the gates are closed. When again flood tide occurs, the water is allowed to enter through the inlet sluice, upper basin getting filled, and this repeats. Okay, these are the classification and working of various tidal power plants. With this, we have completed the tidal power plant section. We shall continue with the next topic in the fourth module in the next class. So thank you for listening.